All right, let's take a look at these practice questions for Module 6. So what we're looking at here is expected value math. All right, so we've got a loan, $15,000, 2-year term. We've got some level of interest. Actually, question 1, this one's extra straightforward. We're just asking about the probability here. So any expected value situation, we need to consider all the possibilities and we need to split them up so that everything is exhaustive and mutually exclusive. So we've got a chance of full repayment, we've got a chance of partial repayment, we've got a chance of no repayment. Forget about how partial, those are the only 3 possibilities, right? Either you get fully paid, you get partially paid, or you don't get paid. So that is exhausting our possibilities, and we can only be in one of those windows. Now, realistically, partial could mean you get 60%. It could be whatever, right? There's a range of possibilities. Here, we're simplifying because we just care about the concepts in the math. So we've got our 3 situations: full repayment, partial repayment, no repayment. Do they add up to 100%? 50 plus 35 plus 15 is 100%. So we're saying there's only one way you get partially repaid in this question. But the probability that you get repaid nothing is 15%. Right? That's just reading the question. So this was, I think, Claude gave me these questions. First one, it's a warm-up. All right, $20,000 unsecured loan. That means there's no collateral over 18 months. And we've got a risk model predicting full repayment with interest, partial repayment, no repayment. And again, 55 plus 45 is 100%. What interest rate should the bank charge to achieve a risk-adjusted return of 2%? All right. So we have to think about, in this case, it's a little more complicated than what's in the quiz. In the quiz, I just ask about a 1-year loan. But we'll take the 18-month loan, and let's go ahead and assume we've got monthly compounding. So our interest rate is going to be something. Let's just put in 5% to start. And then our principal or basic loan was for $20,000. And then our time period I'm going to go down. Oops. All right, that's 18 months. Perfect. Let's see. I don't want to do this. I'm going to simplify this. Let's ignore payments because that's more math than I need you to practice. So if we assume, pay back in full after 18 months. All right, that's the basis of our loan here. So amount owed after 18 months is going to be our principal times 1 plus our interest rate divided by 12 to the power of 18. So we're taking our interest rate, we're making it a monthly rate, so 5% per year turns into whatever per month, and then we've got that repeated 18 months. So after 18 months, this person's going to owe us $21,554.32 if we charge 2%. All right, so let's consider our possible outcomes. A, B, and C. So our value of outcome A is going to be whatever this is. Outcome B is going to be 75% of the total owed. And then outcome C is you get paid 0. And then our probability for each of these, 55, 25, 20. All right. So, to get our expected value, that's just going to be, let me show you the obvious way to do this. For those who aren't super comfortable with Excel, is we just take each value times each probability, add it to the next value times the next probability. And here's why I don't do that, is because it's easy to make these little stumbles. All right, so we could just add it up like that. And so you can see with this particular loan, if you're the bank, you're expecting to lose money because you have such a big probability of not getting paid back all of what you gave out. Let's do this the easier way. We're just going to put those there, and then we'll just sum up that block. All right, same deal. Hey, Ted. Yeah, you're on camera now. This is Ted. Yes, you're a good boy, Ted. All right, there we go. All right, so we've got an expected value given a particular level of interest. Whoops, what the hell did I just do? Okay, cool. We've got an expected value given some interest, and we want to get 2% return. So let's go ahead and let's expand this. And so our risk-adjusted return, thinking about this as a bank, if we're making a bunch of loans like this, we're losing money. Right? So let's start by just putting in a higher interest rate. Okay, so at 20%, this is something like a credit card loan. 25%. So now we're getting an expected value that's bigger than what we're giving up. Right? So if someone pays us in full, we make a lot of money, but most of the time we're losing money. Except that now that we've got this up to 25%, outcome B now has a higher value. Now, we could get more realistic and make a model where if we raise the interest rate, we're going to change the likelihood of getting paid back, and get super elaborate, which is what you would want to do if you worked for Capital One. In our case, real simple, right? Just A, B, C. So B is just a mathematical reality. It's just 75% of the total amount owed. And so if we increase the interest rate, the total amount owed goes up, and this amount goes up. This probability in real life probably changes, but not today. Okay, so to calculate our risk-adjusted return, what we want to think about is how this expected value differs from the amount of money we're putting out. And another thing we should think about here as a bank is, what if we just put this money into treasury bills? Something super, super safe. That would be sort of our point of comparison as economists. We're not going to worry about that here. Here we're just kind of thinking in the abstract for this particular loan. So we're going to make $1,300, $1,400, thereabouts, divided by our initial investment into this. We're getting about 6% there. Cool. So that calculation was just how much money did we make in interest in the expected value outcome, divided by how much did we give up to begin with, which was the $20,000 loan. All right, cool. So we got 6%. Now, how do we get this to 2%? Now, there's two ways we could do this. The simple but laborious way is just plug and chug. So let's try 22.5%. We're closer. 22%. We're almost there. 21. We're overshooting. All right, so we can actually get really close just manually. We're not getting exactly there, but we're getting close enough for homework. That said, to get this perfectly, let's go ahead and use the solver. So in LibreOffice, this is under Tools, there will be something similar in Google Sheets. There'll be something similar in Excel. With Excel, you usually have to activate the add-on, which is ask YouTube if you're using Microsoft Excel. LibreOffice, it's just right here. What we want is we want to target our risk-adjusted return. Go ahead and hit enter. We want to get this to a value of 0.02 by changing the interest rate that we charge. And what can be what? So B1 has to be greater or equal to 0. Nothing else is changing. I don't think we actually even need to worry about this. Right? So limiting conditions, we might put this in if we needed to solve a maximization problem where the global maximization is an economically nonsensical value, like selling negative values of something. We'll see stuff like that in a few weeks, but for now, let's just solve this. No solution was found. The model's not linear. Okay, let's see if we can find something in options. Let's try this experimental one. All right, let's try it again. No. All right. I take it back. Sometimes the solver works, sometimes it doesn't, but as you can see, Plug and Chug got us pretty close. So for this question, if you told me an interest rate of 21.9% or 21.85%, that's a little closer. You could get as close as you want by adding decimals, but 0.218-ish, right? We're pretty close. We basically got it. The rest is just labor and not learning. So we've got that. Let's go back to, let's resize this. Pull this out of the way. All right, what interest rate should the bank charge to achieve a risk-adjusted return of 2%? About 22%. All right, $12,000 loan for 1 year. We've got these outcomes. So let's go ahead and copy this. Move or copy, move to end, and we'll call this Q3. And now we're going to have to change things. So our loan is now $12,000. Our term is now 12 months instead of that. We could just do this simpler formula, the loan times 1 plus the interest rate. I'm going to go ahead and leave in monthly compounding. So notice this. We change this 14,622, 14,901. When we're compounding monthly, we're going to end up paying more interest. If we're the bank and we're compounding monthly, we're going to collect more interest than if we compounded yearly. You've probably seen this in a finance class or a math class somewhere else. Play around with it. You can adjust this. So you could say, what happens if we are doing this yearly? You do this yearly, and we're getting a little bit more. So 14,929 instead of 901. There's a limit to how far we can get, and that version of the math kind of gets easier in a way where we start using E, the number E. I tend not to do that in this class just because it's an extra thing to learn. So in the case of the quiz, I'm expecting not monthly compounding, but yearly compounding. So actually, you know what? Let's go ahead and just leave this as yearly compounding. 14,622. All right. I feel good about that. All right. Payback after 1 year. Annual compounding. Cool. Our numbers would be a little bit different if you did this monthly compounding. So actually, you know what? Maybe let's go ahead and do 2 versions of this. Q3B. Copy. Okay. And here, we divide by 12. All right. So back to here. 40% chance of full repayment. 40% chance of 40% repayment plus collateral. Ooh, we got to talk about this. And then 20% chance of collateral, but no repayment. Maximum interest rate of 25%. Interest capped at 25%. All right, so right off the bat, if we look at this, we're losing money. If we go up to 25%, we're still losing money. This is a good question. Claude did good on this. So we can't go higher than 25% on this loan, so we're going to go up to that limit because we're still losing money at that limit. But what we need now is to add in collateral. Let's spell that right. So let's say we've got collateral is going, and actually we've got to adjust this. This was 40%. Whoops. Oh, crap. Same as other ones. There we go. All right. 40% total plus collateral. So this is going to be 40% of the total plus the value of our collateral. And this is just going to be the value of our collateral. So with zero collateral, we're losing 30% on our investment on average if we're investing this money and giving out these loans. But if our collateral is, say, $1,000, we're getting better. $6,000, we're right at 0%. $6,500, now we're pretty close to that 2%. We got 2.5%. 6,400, there we go. We hit 2% exactly. Let's go back to the question. Banks considering this loan, we've got this stuff at the maximum allowed 25%. What minimum collateral value is needed? Well, the minimum would be whatever gives us breaking even. With a caveat. So a couple minutes ago we said, let's think about our next best alternative as a treasury bond. Right now, treasury bonds are getting 4.5%, something like that. So we might want, say, $7,000 collateral gives us enough that when we account for the risk, when we account for the expected value of this return, we're pretty much matching what we would get with a treasury bond. Maybe $6,800, something like that, right? We could answer this question differently with different explanations. This is the nice thing about having the show your work part of the assignment. If you end up going a little differently than what I anticipate in the answer key, justify yourself. Just make sure you write it down somewhere so that I have a chance to give you those points. In any case, what matters more than the specifics is the general approach. So what we built up in the last couple questions, and actually let's not forget to go, let's just grab this whole block from row 4. There we go. So here we've got the monthly compounding, and notice with the same collateral, our risk-adjusted return is a little bit lower. Instead of 4%, it's 3.5%. Interesting. All right. General approach. Let's talk about that. So we've got this formula to figure out how much are we owed. Right? Our simple future value compound interest formula. In this case, it's really simple. It's compounding for 1 year. The other one was a little harder, compounding monthly over 18 months. The quiz isn't going to be that difficult. The quiz is, I think, just a 1-year loan. It's been a little while since last semester, so don't quote me on that, but go simple, right? Don't make it more complicated than you need. So, we got interest, we got a loan, we figure out how much money should we be getting back in the ideal world, and then we consider the other possibilities, those probabilities of those possibilities, and then we add up the weighted, probability-weighted average of those outcomes to get some expected value, and then we compare that to what we started with to calculate a return. All right. That's a lot of stuff. So, pause, rewind, go back, ask questions, but we got it. So, Our next one, $5,000 loan over 6 months. We've got this. I'm going to do this one relatively quick. So 6 months, I'm going to go over to here. Amount owed, 6 months. Monthly interest over 6 months. This was a $5,000 loan. And we got a 60% chance of full repayment, 30% of 80% repayment, and a 10% of 20% repayment. 60 plus 30 plus 10 adds up to 100. So 20% of this, and our collateral is 0. Cool. And I'm going to add in the reference to collateral just for kicks. 0.1, I think that works. 60, 30, 10, 60, 30, 10. All right. What interest should be charged to ensure a risk-adjusted return of 1.5%? All right, so it needs to be higher than what we've got here. Try 0.25, 0.3, 0.4. We need 1.5, so that's too high. 3.5, we're getting closer. Cool, so we're basically there. The rest is just fiddling. But notice with 0 collateral, we need to charge 34% to get a 1.5% return on our investment as the bank. Right? So if we want it to be easy for people to borrow money, 34% makes it kind of tough for people to borrow money. But if you say added a $5,000 collateral, let's say you're getting a car loan, that $5,000 collateral means that to keep that same 1.5%, we can drop our interest way down. Actually, way down. At 0%, we're still doing pretty well. Actually, this is a slightly weird mathematical example. We're doing kind of well in case B, because we're getting collateral that's worth more than the loan. All right, so no one's going to give us $5,000 collateral. Let's say $1,000 collateral on a $5,000 loan. Now our interest rate at 15%, 20%, 20%. 20%, we're pretty close. Right? At 18% compared to 35% we had to charge without collateral. All right, so we take out the collateral, our return drops, we raise this to 35%, it jumps back up about the same level. $1,000 of collateral makes a big difference on the interest payments that the borrower faces in this case. But this question was asking no collateral. We've got an answer. What interest rate do we charge? About 35%, a little bit less than that. $8,000 loan for 9 months, 70, 20, 10. 70, 20, 10. What do you say, 9 months? Swap this out. Our loan is for 8,000. 70% full, 20% half plus collateral. So let's chain 0.8 to 0.5 plus collateral, and then no repayment plus collateral. So 0 plus the collateral. Bank wants a risk-adjusted return of 3%. Collateral's worth 2,000. So 35% is too high an interest rate. We're getting higher risk-adjusted return than we are targeting. Why don't we just go for this? Well, we're going to lose some customers, and our customers are going to go to some other bank. So let's cut them some slack so we can keep their business. Dropping to 25%, big change. 20% a little too far. 22.5 split the difference. We are just about there. 2.4 puts us at 30%. Or sorry, 3%. Yeah. Again, we can fiddle, we can get a little bit more accurate, but we're most of the way there. So we've got this outcome, the set of outcomes. We want a risk-adjusted return of 3%. The collateral's worth 2,000. What interest rate should be charged? About 24%. Right? Cool. So Again, let me just once over this basic approach. We want to put together information on the interest rate we're getting, the amount of money on the line, our possible outcomes, multiplied by the probability of those possible outcomes, and then we add those up to get an expected value. With that expected value, we can compare that to our initial loan, and that will figure out our return. So here we're making about $250 on an $8,000 investment from our perspective as the bank. $250 on $8,000, that's about 3% return, right? So if we make a bunch of these loans, sometimes we get paid back with interest, sometimes we lose money, sometimes we lose a lot of money, but in either of these two cases, we've kind of got a bottom end of that based on the collateral. Because we've kind of limited that bottom end, we're able to charge a lower interest rate and still pay our bills while still being competitive. All right, so that I think should be more than plenty practice for this module. I think if you get through this, if you can kind of make sense of these, fiddle with the numbers, see what happens, and if you kind of wrap your head around this spreadsheet and make your own version of it, you should have no problem with this quiz. All right, but if you have any more questions, let me know. Send me an email, talk to me in the usual ways, and I will see you in the future.